Trigonometry. So here we go with some ACT and trigonometry. My objective for you on this one is you will understand some basic trigonometric ratios and how they are going to apply to the ACT. So let's start off with something about that. Okay, and what is trigonometry? Okay, let's look at this for a second. Okay, trigonometry is really the study of two different things here. Most of what you've seen is from, say, studying trigonometry through a triangle. If you were in pre-cal, you would also realize that there's a way to study this in, say, a circle, but that would actually be next semester. So, or if they had gotten this into Algebra 2, which they usually don't. So really kind of comes down to, let's think about the triangle, because that's really what the ACT is going to be focusing on. They're going to focus on how do we understand trigonometry from a triangle perspective. Okay, and there's three basic trigonometric ratios that you need to know, three basic trigonometric functions, whatever you want to call them. I'm going to go back here a bit. You need to know sine, which is opposite over the hypotenuse, adjacent, which is cosine, which is adjacent over the hypotenuse, and tangent, which is the opposite over the adjacent. Now, if you draw a triangle, notice where I put the little theta. This symbol right here is called theta. All it means is what angle are you using? Okay, so there's the hypotenuse. I can draw, let's say, a line across the triangle that will go to the opposite side, and then the line that I can't, or the line that touches to make the angle, would be the adjacent. Notice I'm doing the same thing here, showing you where's the opposite located, where's the adjacent, depending on where the angle is located. Okay, so how do I do this? What does this look like? Well, here's an example. Here's a triangle, and I'm giving you the angle sides and the little measurements of the sides. The sides? Just the sides. Whatever. It's late in the day, I think. So on and so forth. Okay, so from here I can answer what is sine A, what is cosine A, what is sine or tangent of A. Now, notice again, what's the opposite side? Well, the opposite side would be, draw a line from the angle, there's your opposite side. The opposite from big A is little a, little a. Anyways, so that would mean my sine is A over B, because B is my hypotenuse. But sir, C is the hypotenuse. This is an example. Go based on this. Forget your Pythagorean theorem for a minute. Anyways, cosine. Cosine would be the side that's not the opposite. So the side that's adjacent, which means it's touching the angle or makes the angle, which would be C, or the hypotenuse, B. Or think that it's the only other side left. Tangent would be A over C. Notice how this is slightly different, but kind of similar to cosine C. And I'm going to show you. My opposite side, I drew it in red, and then I went ahead and started labeling my sides. Okay, notice how there's a little bit of similarity in some of these answers. That would also be something very big and key if you ever took trigonometry. All right, so here's an example with some numbers. Numbers? Really? Okay. All right, sine of A is equal to 12 over 13, and cosine of A is equal to 11 over 13. Then, what is tangent of A? All that means is this. Take out the hypotenuse. Okay, this is your opposite. The 12 is your opposite. The 11 is your adjacent. They make up tangent. So, opposite over the adjacent, and you're done. Is that easy? Yes, it is. Here's another example with some numbers. In the triangle below, if sine B is equal to 5 over 13, what's the value of tangent A? Okay, so let's start putting the numbers where they belong. Obviously, the 13 is the hypotenuse, so that goes there. 5 would be the opposite side. So here's my opposite side. In case you didn't realize that, again, opposite of B. All right, so if you look at this, what is this? I need to go backwards some. Okay, I should have done that. Okay, what does this look like? This looks like Pythagorean theorem. Well, by golly, I think it does. All right, so here I got 5 squared is equal to, let's say, x squared is equal to 13 squared. So solve and take the squared. If you do that, you'll get 12. So that means tangent is the opposite over the adjacent, so it would be 5 over 12. Or I'm sorry, ooh, I wasn't paying attention. Oh, look at me not paying attention. Notice this is tangent A. So now I'm saying opposite of A, which is 12, over the adjacent, which is 5. So the answer is 12 over 5. Oh, I gotta be careful. Oh, see, I was even tricking myself. Okay. Here's something else very important. And I bring this up because I saw this on question 19 of your part 2 of your test. If you look at a coordinate plane, in trigonometry, they divide this up into like sectors. And they talk about this, what is called radians. But what you need to know is this. At the very top is 90 degrees. All the way across is 180 degrees. And then 270. And if you know those, you're okay. Now, they use something else, what's called radians. And that's something that the Greeks came up with, and just go with it. But 90 degrees is pi over 2. 180 degrees is pi. So keep in mind that 180 degrees is called pi radians. And this is a lot of where pi was coming from, where they were developing pi. So just kind of go with it. And 270 degrees is 3 pi over 2. And then keep in mind how the signs look. Plus, plus, minus, minus, plus, plus, you know, that type of thing. I think if you know 0 and pi, you could easily figure out pi over 2, 3 pi over 2. But that's just me. But this is something I think you might want to know. I mean, it may not appear in every test, but maybe it appears in your test on Saturday. Then, kind of go from there from this. Let's look at this problem. Look at problem 19 from part B, or part 2 of the test. If sine of theta is equal to negative 3 over 5, and theta is between pi and 3 pi over 2, which means it's between 180 degrees and 270 degrees. Okay, so it's in this little area right here. Now, keep in mind this. This is a hypotenuse. So maybe you draw a triangle from this. It doesn't really matter how you draw it. I mean, obviously it should, but we can work with this. Just keep in mind that the 5 is your hypotenuse, so make it a slant. So here's my slant, or my diagonal, and I make that a 5. Notice that the negative then could be this negative 3 right here. So I want to cross on the x, and that means I need to go down. And you should know your 3, 4, 5 triangle. So that means your tangent is equal to negative 3 over 4, negative 4. Because I went to the left, I went down. Remember, this is negative and negative. So that means the opposite and the adjacent were both negative. The hypotenuse would have to stay positive no matter what. Okay, so negative, negative, and that would become positive 3 over 4, and you could easily pick that as your answer. So that's one way to do that problem. Probably a safe way to do it. And that's kind of a beginning. Now you're seeing some ideas here, and we'll discuss how you can look at the answer choices. Maybe those can help you out. But the reality is this is most of what is covered as far as trigonometry is concerned. According to the study guide, this is at most 3 or 4 questions. But maybe these are 3 or 4 questions that are fairly easy that you could actually get, and maybe get you that 19 that you need. Anyways, just a thought. If you do have any questions, feel free to ask. We're going to do an assignment on this, and I look forward to helping you with it. Thank you very much. Take care.